All right, here's our video on ellipses. The first thing I want to say is to go to your Google Classroom and find the ellipse video that I posted. It's not my video, it's one I found on YouTube that just has some good descriptions on how ellipses are practically useful, and it has a good simulation for how to construct an ellipse. What I'm going to do here is just assume you've watched it or you have a basic understanding, and I'm just going to jump right into the notes. Some characteristics of the equation for the ellipse is that it's got two square terms, both of them are positive, and their coefficients are different. So if you look down here at these basic equations, there's a plus between them. Their coefficients are the a squared and the b squared. They're different. We have a graph here of a horizontal oriented vertex. They can also be oriented vertically like this. And we'll talk more about that in a minute here down at the bottom of the notes. One thing I want to talk about here with this picture that's drawn is that we have our two foci right here, and the major axis goes through the foci. Where the okay, well, let me do this. So this is our major axis being this line, and this is our minor axis. So the major axis goes along the length of the ellipse, and the minor axis goes along the width. So this minor axis will be shorter than the major one. The major one also contains the two foci. We have a center point here, and then right here, the point on the ellipse that's also on the major axis, this is called a vertex. And the similar point on the ellipse and along the minor axis, this one is a covertex. So when when the vocabulary here has vertices and covertices, that's what we're talking about. There's two vertices on the ellipse, one here, one at the other end, and then there's a covertex here on the minor axis, and then one over here on the other end. These are our general equations, and these are the standard form. I'll be focusing on the standard form down here. So if you notice, these two equations look very similar, and they're almost exactly the same. The change is this. The difference is that this one has a squared first and b squared second, and this one has the opposite order, b squared first and a squared second. And so here's what I want you to write down, or one thing I want you to write down over here is that a squared is greater than b squared. So whenever you see a squared in these formulas, it's going to be a larger value than the b squared. And whatever variable a squared is under, and I mean, for example, here that a squared is under the x group, and over here a squared is under the y group, that's going to determine whether you have a horizontal or a vertical orientation. So a squared is bigger in this first equation. A squared's bigger and it's under x. So for this form of equation, we're going to have a horizontal direction or orientation for our ellipse, meaning it's going to be stretched longer left and right than it is up and down. And then in this equation, the a squared is under the y variable, which means in this form, it's going to be longer or taller vertically than it is horizontally. So the direction here will be vertical. Like this. So that happens when a squared is under x, it's a horizontal orientation, and when a squared is under y, it's a vertical. And then each of these will have a minor and a major axis. The major axis goes along the center of the length of the ellipse, and the minor goes along the center of the width. Where they intersect is your center, and the two foci are always on the major axis. On a vertical oriented ellipse, we would have this as our major axis. This would be our minor. So our center would be here, and then the two foci would be somewhere like this on the major axis. So the major axis is the longer axis, the minor is the shorter one. Now we have some other things that I want to label here. The length from a vertex here to the center is going to be called A, and that's what we'll get our A value for our equation. That length is A. It's also half the major axis. Half the minor axis, so from the center to the co-vertex, is B. And that's the same B as is in the standard equation form. And then we also have this distance that we care about from the center to a focus, and that is what we're going to call C. And that's not part of our equation, but it's still useful information. In a vertical orientation, A is half the major axis, so A here, this half could be A as well. B is half of the minor axis, and then C is from the center to a focus. Now we have an equation that relates A, B, and C together, and it is this. C squared equals A squared minus B squared, and we'll use that in some of our practice problems. And then just a few more notes I want you to write to yourself. A is half the major axis. B is half the minor axis. And C is the area or the distance between the center and a focus point. All right, so pause the video if you need to keep that on the screen and copy any of that down. All right, so some practice problems on the back. I want to take a minute and have you set up your notes in a way that matches the practice problems, the homework problems that you're going to do. So I'm going to put up on the screen some things I want you to pause the video and write down. So I wrote these here because they match what your homework and practice problems are going to be asking you to find, and I want to be sure that we do that in our notes. So pause the video, copy these down for the first example and the second example, and then come back and we'll work through it. The first thing we're going to do is find the bigger denominator, and for this first problem, it's right here. And the reason we're going to do that is because remember I said that A squared is bigger than B squared, so that 9 represents my A squared, and the 4 represents B squared. And that's also going to determine the orientation of my ellipse. So if the y has the bigger denominator, that means my ellipse is going to have a vertical direction. And then here is my standard form equation with a squared under y and b squared under x. So we can see that our center is our hk, and there is no hk, so we know it's 0, 0. A squared is 9, so to get my a value, I just take the square root of what is a squared. So the square root of 9 is 3, and then b is the square root of my other denominator, which is 2. C we'll figure out here in just a minute. The length of the major axis is twice whatever A is, right? Because this is from the vertex to a center, and then we have another 3 from the center to the other vertex. So that's going to be 6. The minor axis is going to be 4. So I'm going to go ahead and graph those and then talk about C in a second. Sorry, see, I already made a mistake. It's a vertical orientation, so I should have been counting 3 up from the center and then 2 left and right. And now to find c, we're going to use the formula I mentioned. A squared and b squared are already in the formula, 9 and 4. We subtract them. We get 5. We square root both sides. So c is plus or minus 5, the square root of 5, which is approximately 2.2. Now that's going to be on our major axis, and it's 2.2 from the center. So I'm going to go up 2.2 and down 2.2. And there's my ellipse with my foci. My c values were plus or minus the square root of 5, and the coordinate pairs for my foci, so my original center is 0, 0. I added 2.2 in the y direction. You can put 2.2 or radical 5, and then I subtracted it in the y direction, so only my y coordinates changed. And I'm going to give you a minute to do the next example, but there's a little bit of setup that I want to do. If you notice it's not set up correctly, our standard equations are equal to 1. So to get that set up here, I'm going to divide everything by 16 and then rewrite this as x squared over 16 plus y squared over 4 because I simplified 4/16 and then 1. So you take a minute and try this problem from there. All right, here's my work for that problem. My first step was to find the largest denominator. It's here under the x. Therefore, this is a horizontal orientation spanning left to right, and is the largest length. So that's my major axis. That's also my a squared, and so then the 4 denominator would be my b squared. And I used decimals here for my c and foci instead of radicals. I take either one. So pause the video and check your work with that. For the next two, we're going to be writing equations, and before I explain this example, I want you to draw your given information, and then I want you to decide whether this is going to be a horizontal or vertical oriented ellipse from the given information. All right, I hope you realize that this was a vertical oriented ellipse because the distance from 0 to 4 going up was greater than the distance from 0 to -3. So that means this is our major axis right here. It's the longest length. And then this is my minor axis. So if it's a vertical orientation, then a squared has to go under my y value. So I wrote the general standard form with the a squared under the y. Therefore, b squared goes under x. H and k were 0, so that gives me x squared and y squared for my numerators. And then I took that b value of 3 and squared it for 9, and the a value of 4 and squared it to 16. And then in this next problem, we are going to do completing the square. I'm going to start by grouping the x's together, and then the y's together. And now I'm going to complete the square. First, anytime you have an a value that's not 1, you have to factor it out of both terms. And then I'm going to leave some room here to complete my square in a minute. And I'm leaving some room outside the parentheses to finish off my completing the square method. So we do -10 divided by 2 is -5, squared is +25. If I'm adding that in the parentheses, I want to subtract it outside. But it's not just 25, it's 9 25s. And that is equal to 225. And then in this group, I take half of b and square it. That gives me -3 squared, or 9. I have 16 nines that I need to subtract outside, which is -144. So then we factor and write our groups, our trinomials, as binomials squared. -225 cancels on both sides. I'm going to add -144 to the other side. And then the very last thing we need to do is get 1 on the right. So I divide everything by 144. I simplified these fractions.